Hello students. In this video we are going to discuss projectile motion again, but a particular condition of projectile motion where we will be discussing that when a projectile is fired along the horizontal from a certain height, then the projectile moves in a parabolic path. That we are going to prove that, and then we are going to find out the time of flight, then its velocity, the direction of velocity, the magnitude of velocity, and we were also going to find the maximum horizontal range. So all these things we are going to discuss in this video. Go through the video very carefully. See, what we consider first here is, suppose we take a coordinate system. Let there be x-axis, okay, and let there be y-axis again, okay. So we have both the axis, x-axis and y-axis, and suppose a projectile is fired along the horizontal. Now it cannot be fired from the origin, because if it is from the origin along the horizontal, it won't be a projectile. We have to fire the projectile in space. So along the horizontal from a certain height. Suppose the height here be given by h. So from a height h, it is projected in the horizontal direction. So let this be the direction with a velocity u. But the projectile moves in its parabolic path as shown here. This is the path which the projectile will follow. Now, what first we are going to do is just find out that the projectile moves in a parabolic path. Parabolic path. So let us see whether it moves in a parabolic path. The equation for a parabolic curve is y will be directly proportional to x square, or we can also write x to be directly proportional to y square. So now to prove that the path or the trajectory is parabolic, we have to prove either y is directly proportional to x square or x is directly proportional to y square. So first of all, let us consider that the projectile be at a particular point at some time t. So it has covered a horizontal distance. Let the horizontal distance covered at this time be given by x, and it has also covered a vertical distance. Let the distance be given by y. So we know the formula for displacement. So s equal to ut plus half at square. Now along x-axis, it will be x is equal to uxt plus half axt square. Now along x-axis, at time t, it has covered a distance x. So we can write the equation x is equal to ux, the initial velocity. Ux is given by u, and t is there. T is the time, so it is t here. The value of ax is 0 for a body thrown into the space along the horizontal. The acceleration is 0. So we have this equation, x is equal to ut. Now similarly, along y direction, the distance traveled is y, so uyt plus half ayt square. Now in this equation, y is the displacement along the y-axis as we have shown here. So y is equal to the value of uy. Initial velocity is along the x-axis, which is u, along the x-axis. So its component along the y-axis will be 0, because this angle is 90 degree, and if you want to find the component u cos 90 is 0. So along y-axis, the component of velocity is 0. So uy is 0. So the first term will be 0. And the second term, will be half acceleration ay is equal to g in the downward direction. So half into g into t square. That is, we are getting the equation y is equal to half gt square. So these two equations we have obtained, one along the x-axis, another along the y-axis. The values of displacement are given. Now from the first equation here, t can be written as x by u. If we put the values here, so y will be given by half into g into the value of t we are putting here, x by u. So x by u square. So finally the value of y can be written as g by 2u square into x square. And from this equation you can see here, we can easily write y is directly proportional to x square. So y is directly proportional to x square, which fulfills the concept of the parabolic path. So that's why we can say that the motion of a projectile is in a parabolic path. So I hope this is very clear to you. Now, next what we are going to do is we will calculate the value of time of flight. That is, how much time it is required for the projectile to reach the ground level. So let us see how it is done. Let me rub this off first. Okay. So the time of flight, it is the time in which the parabola, that is the projectile, traverses the path in space. So therefore we write here the second point that we are going to discuss is time of flight. See, when we consider the time of flight, it is the time for the projectile to reach the point here from the top to the horizontal plane here. So it has traveled a distance h here. So horizontal distance which is traveled here is h. So we have the formula x is equal to uxt plus half axt square, right? So and for y-axis we can write y is equal to uyt plus half ayt square. Now look at the second formula here, the vertical distance which is traveled along y-axis. So it is y is h is equal to uy is 0, half ay is g, and time of flight is given by capital T. So the time required to reach the ground by covering a distance of h along the vertical. So this will be the formula here. Small t is replaced by capital T. So from this we can simply write the value of the time of flight, which will be given by root over 2h upon g. So this is the value of the time required by the projectile which is thrown from a particular height h in the horizontal direction. It takes that much of time to reach the ground. So I hope this is clear to you. Root over 2h upon g. So we got this value also. Next we are going to find the horizontal range. This time of flight we have calculated, root over 2h upon g. Now the third point that we are going to discuss here is horizontal range. Horizontal range. Now to understand the concept of this horizontal range, let it be given by r, the maximum distance traveled in the horizontal direction. So along x-axis the displacement is x is equal to uxt plus half ax t square, right? So the value of x, which is the distance in the horizontal direction, it will be given by r. So r will be equal to initial velocity along the x-axis is u, the time taken to reach the ground is capital T, and the value of ax is 0. So we can write here r, which is equal to u into the value of t we have already calculated, it is 2h upon g. So the value of r, that is the horizontal range, is given by 2h upon u into root over 2h upon g. So I hope this is also very clear to you. So if this is clear, then we move to the next part, that is we will find here the velocity. Let us find the velocity here. We have calculated the value of r. Let me write it here, u into root over 2h upon g. Now fourth point, magnitude of velocity. Suppose at any point, suppose you consider this point, and at this point, this is the direction in which the body is moving, velocity v. It has component along x-axis given by vx, along y-axis it will be given by vy. So we know that the velocity will be given by root over vx square plus vy square. So this value of velocity vx, let us first find the value of vx. V is equal to u plus at. This is the general formula that we write. So vx will be ux plus axt. So ax is 0. Ax is 0. So ux is u. Initial velocity along the horizontal is u. So we write vx is equal to u. That is the value of vx that we have calculated. Then vy. Vy is equal to uy plus ayt. Now the value of vy. Uy is 0. Initial velocity along the vertical is 0. And the value of ay is g into t. So we have the value of the velocity vy, which is the vertical component, which is given by gt. So therefore the value of v will be given by root over the value of vx square, that is u square, plus vy is gt, so g square t square. So this is the value of velocity, the magnitude of velocity that we can consider at any point of the path. And the last point, that is direction of velocity. Direction of velocity. To understand the concept of direction of velocity, let this be the direction. Like the velocity makes an angle beta with the horizontal. Then obviously we can write tangent beta is equal to vy upon vx, and which means tangent beta can be given by the value of vy we have already calculated, it is gt upon vx is u. So this is the value of the direction. Beta represents the angle which the velocity makes with the horizontal direction. So this is beta, which is gt upon u. So you can see here, these are the values which we have obtained, different values. Velocity we have considered here, the value of velocity, which is root over u square plus g square t square. We have calculated, first of all, we have proved that the path is parabolic in nature. Secondly, we have calculated the time of flight, which is root over 2h upon g. Then the horizontal rate, which is u into root over 2h upon g. Then the magnitude of velocity, which is root over u square plus g square t square. And lastly, the direction beta, tangent beta is gt upon u. So I hope these are very clear to you.